Well, today we're going to make this handy mortising jig. It's perfect for making slip or loose mortise and tenon joinery. Now, if you're not familiar, loose or slip mortise and tenons just mean that you put a mortise in both of your work pieces and then you cut your tenon stock separately. And the word loose is not my favorite descriptor there because it's not really a loose joint. It's actually a very good, tight-fitting joint if made properly, but it's just one of the terms that we use. So this jig is incredibly useful, not just for simple 90-degree joints like in a door frame, but also angled joints, twin mortises, and mortises in odd-shaped components. This entire thing is made from just a portion of a single sheet of 3/4-inch plywood, and at the heart of it is Microjig's match fit system and the match fit ratcheting clamps. The top adjusts in and out for varying material thickness, and it locks down using Microjig dovetail track screws. The vertical clamping plate features a series of dovetail slots that can accommodate shop-made fences, as well as all various clamps in the Microjig match fit line. So you'll be able to hold just about anything, anywhere, and put a hole in it. Now, to make use of this jig, you will need a plunge router outfitted with a 5/8 of an inch guide bushing. You could then use any bit that you want that's a 1/2 inch or under to make your mortises. And perhaps best of all, you can download our free plan if you'd like to make your own. All right, let's dive into the construction. Even though Baltic birch still costs $1 million a sheet, I went with it for this jig since it's really hard to beat when it comes to stability and flatness. But any stable plywood or sheet good can get the job done. The cut list will lay out the various part dimensions so you can just cut them to size using your circular saw, track saw, table saw, or whatever you have on hand. One of the many cool things about the Microjig ratchet AP clamps is that they engage perfectly with most track systems. I usually cut my parts slightly oversized with the track saw and then make the final cuts at the table saw for the sake of consistency, especially when we have so many parts that share dimensions. I could then use the miter saw to cut the narrower parts to length. Anytime I work with plywood, I'm careful to knock down the sharp edges just to avoid potential splintering. First up, we're going to cut some dados in the underside of our top, right here, and then also in our subtop, which will then accept runners. These are going to allow the top to move forward and back in a nice, clean, and smooth motion. The dados are in the same location on both pieces, and the same depth, so we can make all 4 cuts with the same exact setup. For the runners, I'll use some 1/4 sawn white oak and sneak up on the fit with the planer. I'm not really going for super snug here, as the pieces should easily slide without actually being loose. We'll glue the runners to the subtop later. Next up, we're going to cut the 2 dovetail slots in our subtop that'll accept the hardware, which will allow us to lock this top in position wherever we need it to be. The first step is to rough out a groove using a router bit or a dado blade. Mine is about a 1/4 inch wide, and I use the Microjig setup gauge to establish the correct height. So the whole point of this first step is to clear the waste so that our dovetail bit doesn't have to do as much work for the second step. It saves wear and tear on the bit, makes the cut easier, and the results are better. By the way, the process here will be the same anytime that we have to make these dovetail slots. The Microjig setup guide is pretty cool because it actually has multiple uses. We already used the square one for the first cut. The dovetail shaped one is just a little bit higher, and that's for setting the height of the dovetail bit. Microjig's dovetail bit also has a laser line that you can use to set the height if you don't have the setup gauge. You'll also notice a line on the shaft that helps make sure that the bit doesn't go too deep into the collet. Microjig's dovetail bit has a lot more going on than a regular dovetail bit. They put a lot of thought into the cut profile, but the most important thing that I'll point out is how they have a slightly rounded profile at the top. The result is a tear-out-free, smooth dovetail groove, which makes life a whole lot easier after the cut. With the height set and the fence set, I can make the 2 cuts. Now, to prevent the piece from twisting, I back it up with a piece of scrap. And you can see the hardware engages with the slot perfectly. Next, we need a couple of holes in the top for the hardware bolts to go through. The holes should be just a bit larger than the bolt diameter, though the exact number isn't critical. In fact, mine are just a little bit more snug than they should be. Just a quick test run as a proof of concept. The only purpose of these guys is to slide back and forth when loose and to stop the top from moving when tightened. Okay, so now we can glue those runners into the subtop. Glue and clamping pressure is about all we need, and be sure to clean up any squeeze out since that'll definitely affect the ability of the top to slide. At this point, you really want to evaluate the sliding action of the top. If anything, it's likely to be a bit too tight, and you could just sand or scrape the sides of the runners to make room. Just keep in mind that nothing is really sanded at this point, and the parts will be waxed later, which will definitely impact the action of the top, so maybe don't get nuts just yet. Ooh, I think it's time for an Oreo break.
He's a good boy. He's a good boy. He's such a good boy.
So next up, we need to make a slot. We have to have a slot here for our guide bushing, and it's a 5/8 guide bushing, and that will allow it to ride back and forth when the guide bushing is in our router. So the bit that I have here is a 1/2" bit. That's a little bit smaller than 5/8. I just don't have a 5/8 bit. Chances are you probably don't either. So we're gonna have to do this in 2 passes, but you really need to be careful and systematic about this and how we approach this bit. So the first pass is going to be on this side. So I've set my fence up so that my pencil line is right in line with the wing of the bit. So pass number 1 will clear out this front section and we'll have a little bit left over here. So with pass number 2, we'll be able to go to our second line with the material being cut away at the front of the bit. What we're trying to avoid is cutting away material at the back of the bit, because then when we're running it in our right to left fashion, you can create a little missile if you're cleaning off material from the back side of this bit. So we're going to approach it first pass here, second pass here, keeping the material in front of the bit. And of course, we're going to have to do this in multiple passes, working our way up through this piece of plywood. Now I know it's tricky to see, but I do have pencil marks on here locating where my slot's going to be, my start and my stop point for the slot, as well as my center line. And I bring the start and stop points over to the edge. The reason I do this is as I'm making this cut, it's kind of blind. I can't really see what's happening with the bit. So I need to know where my start and my stop points are. So let me show you how we're going to figure that out. Using a very large square or a piece of scrap, something that's going to be big enough that the pencil lines can go outside the workpiece so we could still see them. I'm basically going to take my bit very carefully, rotate it so that my wings are going left to right. Basically, I want them to be as far as they're going to cut. So I could take my square, ride along the fence. When it hits the router bit, I can come out here. Whoops, that doesn't help if it's tilted. I'll come out here and draw a line. Now I have a black laminate here. With the proper lighting, you can see that pencil line very easily in your shop. I don't know if you guys can see it from the vantage point of the camera. Okay, I'll come on this side and now draw that line. And now when I'm actually making these cuts, I should be able to see right here how the pencil lines on the workpiece relate to the location of the bit. So for instance, if we were starting the cut, we would start here, so the bit is within that area, go all the way across. Here comes my stop point, and I stop on that other line. Drop cuts can be a little scary at first, but the key is to make sure the piece is held firmly against the fence as you slowly drop it down. It's also important that we don't take too much of a bite at once. And I should also mention that I highly recommend you only do this operation with a spiral bit, as those are much better suited to a plunge cut than a bit with straight cutters. So hopefully you can see what I'm doing wrong here. The bit is cutting up here and my pencil lines are down there. Obviously I got turned around and I'm just about to notice it. Thankfully that's just a cosmetic flaw, so nothing to do but laugh and move on. Now something that didn't occur to me at the time, but you might consider, is only cutting about halfway through the thickness. Then you could flip the piece over and finish the cut from the other side. This prevents the bit from having to protrude so much from the table. Once we punch through, I can adjust the fence to make the second cut. Now this one is conservative because I really want to sneak up on the perfect fit. Each time I nudge the fence slightly, and then test the fit with the guide bushing. I want the bushing to slide back and forth with a little bit of effort, but we definitely don't want it to be loose. Now we need to cut this shallow groove that'll accept our metal stop material. I'm using 1/8 inch thick by 1/2 inch steel stock, but you can use aluminum, plastic, or wood, whatever you want. I want the groove to be centered on the slot that we just cut, so I mark it out and head back to the router table. I'll use the same 1/2 inch bit that we used before to make the grooves. The stop strips should slide easily back and forth, and they should be flush or just a bit recessed. We need a hole in the strips for the dovetail hardware about 1 inch from the end. By the way, the match fit clamps also engage perfectly with the slots on my drill press. Notice that my bit drifted slightly when I did the drilling and the hole isn't perfectly centered. So to adjust for that, I'm going to mark the hole location on the groove. The center line of that hole is where we're going to route another dovetail groove that will accept the hardware. For this one, the setup gauge is no help because we actually need to recess the dovetail groove a little bit deeper than we normally would. So I line it up by eye using the laser line on the bit, making it even with the bottom of the groove. At the table saw, I'll plow out the bulk and then make the final pass at the router table. All the components for our top are done at this point, so let's see how it works. The stops slide nicely and tighten down securely, so I think we've got a winner. Before moving on, I'm going to apply some wiping poly to the mating surface of the jig. I really want to seal it up so that I can apply some wax and reduce friction as much as possible. Oh yeah, that's the stuff. Next, we're going to make this vertical clamping plate here. The spacing of the grooves, that's really totally up to you, but I think what we have in the plan will satisfy most people's needs. I'll lay out the groove locations based on the plan and make sure that my center lines wrap around to the edges. From there, I can make the first cuts using the dado stack at the table saw. Because it's a symmetrical layout, I can make 4 cuts per setting, rotating the piece as I go. And of course, only 2 cuts for the center. Now we can do that same cutting process, but at the router table, rotating as needed. Well, pardon me while I interrupt this groovy footage to let you know why I think Microjig's new ratchet clamp AP is awesome. They engage with any match fit dovetail slot for holding pretty much anything, anywhere. The clamp also engages with a lot of standard T-tracks and regular dovetail slots, as well as being compatible with track systems as I showed earlier. The ratchet clamp AP also features an anti-pivot spring that keeps the arm up and prevents it from falling down. So now it's much easier to position the clamp and your workpiece as the head only moves when you want it to. The ratchet system gives you several stages of clamping force, and you'll hear the satisfying clicks as you tighten it up. The quick release trigger disengages the clamp, allowing you to quickly adjust its position and re-engage. Oops. Obviously, we're going to be using these clamps today in the context of this mortising jig, but they're also handy for use around the drill press, the MFT, and anywhere else you want to cut a dovetail slot for work holding. Microjig also has an extensive library of free project plans that you might want to check out for inspiration. Find the plans and pick up your own set of match fit ratchet clamps at microjig.com. Unfortunately, the capacity of the fence won't allow me to make the centermost cut. So for that, I clamp on a tool guide front to back, and that's going to allow me to make use of the larger dimension of the table. The Microjig bit does a really good job of not leaving a bunch of frayed material, but I want these slots to be as smooth as possible, so I'll hit the inside walls with some 180 grit sandpaper. Next up, we're going to make some fences. All we really need is a thin strip of plywood with a couple of slots cut for the hardware, and that's going to allow these pieces to move around as needed to just about any angle. You've seen the drop cut thing already, so this is no different. We just have to stop, skip a few inches, and then plunge again. And this time, I did the thing that I mentioned earlier, only going halfway on each face to make the through cut. The less we have of that bit sticking up, the better. Now you don't really have to do this part, but I thought that the fences might work a little bit better if they have slightly rounded profiles at the top. Totally optional. Alright, let's test them out. The idea with these things is that they should be able to move to just about any angle and any position to help support our workpieces for repeatable cuts. So now we've got our top assembly and our front clamping plate. All we need now is a sturdy base. The base will have the bottom piece, 3 ribs, and our subtop. I'll assemble everything with glue and clamps, working with the front face down on the bench so that those pieces all stay in the same plane. With clamping pressure applied, I can make any changes I need to make sure that the components are nice and square. And the most important thing is that the front is square to the top. Now I can countersink and drive some screws at each joint. Next, we'll attach the clamping plate. I'll pop in a few brad nails to stop the piece from sliding around, but then secure everything with screws. I'll check it for square once again, but honestly, if it's not square at this point, you're in trouble. So make sure it's square before this stage. And let's get this thing together one final time. Of course, if you don't have an Oreo, you can skip this final step. What do you think? It's pretty nice, right? So now we're going to make some setup helpers. First, we need a piece of 5/8 stock that fits snugly into our slot. We'll cut one portion off and mark it with center lines, and that's going to help us when aligning our workpieces. The other pieces can be cut to very specific lengths as spacers that correspond to different length mortises. Now, to calculate the size of any of these spacers, we have to think about the bushing and its relationship to the bit that's in there, and that's going to change depending on which bit we use. What won't change is the size of the guide bushing. So let's imagine this is our 5/8 guide bushing, 5/8 of an inch, and this is from the outside edge to the outside edge, not the inner, outer. Now let's say we have our 3/8 router bit, okay? We know that is 3/8 of an inch. So what we need to account for is this space right here from the router bit to the edge of that 5/8 guide bushing. And in this case, it's going to be 1/8 on each side, right? For a total, if you take that gap in total, that's a 1/4 inch gap. So now the math becomes very easy. If we know we want a 2-inch mortise, what we need in terms of a spacer is a 2 1/4 inch spacer. Now using this bit, whoops, that needs an R. Any size mortise we want, we simply add a 1/4 inch to the spacer and that center line, and that will give us the perfect length mortise we're looking for. But we always have to use that 3/8 bit. Now what happens if we go, let's say with a 1/2 inch bit? With a 1/2 inch bit, our gap on this side is a 1/16, and our gap on this side is a 1/16, which is a total of an 1/8. So it's almost exactly the same thing we did before, but instead of adding a 1/4 inch, we only add an 1/8. So we want a 2-inch long mortise. We need a spacer that's 2 1/8 of an inch long. All right, it looks pretty good. Seems like it's going to work, but let's put it to the test by building a simple door frame. Okay, I said a door frame, but I'm going to be lazy and only do one joint with a rail connecting to a stile. I'll start by putting center lines on the end of my rail. In case you haven't noticed yet, everything with this jig relies on center lines. While we don't necessarily need center lines on the stile piece, they're nice to have just to confirm alignment until we gain some confidence in our new jig. On the jig itself, you'll want to take the center line of the guide bushing slot and transfer that to the inner wall. That just makes it easier to see when our workpiece is in the correct position. Now I can insert my centering block to set the front to back position of our jig top. When the pencil lines line up, we could lock down our top. To set my side-to-side stops, I use the spacer that we made previously that'll yield a 2-inch long mortise. I simply drop it in the slot, line up the center line with the center line on the workpiece, bring the 2 stops in and lock them down when they make contact. And now I just need to line up my rail piece and clamp it into place. I could then put the fence in position so that I can make the same mortise on any other workpieces that need it. With the guide bushing installed in my router, I'll insert the 3/8 inch bit and set the depth. Remember to account for the fact that the top of this thing is 3/4 of an inch thick. Just for a little extra security, I'll add another ratchet clamp. And now the easy part. I work my way down about a 1/4 inch at a time until the mortise is completely cut. Man, I really need to remember to put a hand on the workpiece when I disengage the clamps. Now if we were doing a real door, we'd repeat that mortise on all of our rails before moving on to the stiles. For the stiles, the mortise will go on the edge of the board. Fortunately, we can still use the fence that we have in place as our stop. I just want to confirm that the center lines line up when we do that. Now I round the mortise, and Bob's your uncle. Look at that, a nice clean mortise. Now for the tenons, I just milled up some scrap to thickness that gives us a nice slip fit in the mortise, and the width of the piece should go from one end of the mortise to the other. I use a round over bit to round the ends, and then cut the stock to length. And just like that, we've got a perfect mortise and tenon joint, nice and level on the face, and even on the edge. So let's see what else we can do. How about a twin mortise and tenon joint? Now this one shouldn't be much different than what we've already done, since I'm making the spacing symmetrical. I cut the mortise on one side, rotate the workpiece, and then cut the second mortise. For the adjoining piece, we can cut one mortise with the current setup. And to cut the other mortise, we'll need to move the fence out of the way. You can see that to make these mortises systematically, you're going to need to strategize things like the fence position and your cut order. So now we can just drop in a couple of our tenons and boom, a sturdy joint if there ever was one. And look at that, nice and flush on the face and the ends. Okay, so what about odd-shaped pieces? Let's put a mortise in this giant dowel. And how about a mortise in some mitered pieces? Bottom line is, as long as you can draw center lines on it, you can put a mortise in it. There it is, a handy mortising jig for making incredibly strong classic mortise and tenon joints with the help of Microjig's ingenious clamps and components. So in hopes of heading off some of the comments and maybe questions that come in, let's get something out of the way. There are so many ways to create mortise and tenon joints these days, and I'm not here to argue the merits of one versus the other, but what I will tell you is this is a great option. And before anyone says, hey, you stole this design from Philip Morley, well, Philip's a good friend of mine. The Morley Mortiser is definitely a predecessor to this one. I feel like I've made a couple of little improvements on it. But if you go back further, Philip's is inspired by Michael Fortune's, which was in a 2008 article in Fine Woodworking. And prior to that, Lee Jigs, the company that makes the dovetail jigs, also has a tool called the FMT, the frame mortise and tenon jig. And I believe that thing was introduced in the 90s. Somebody correct me on that exact date, but it's been around for a while. So this stuff goes back a lot further than just what we can find on YouTube. The best ideas don't really happen in a vacuum. They happen with collaboration, shared experiences. So I hope when you guys see this jig, even though mine is an improvement on things that came before, I want to know what you would do to improve this jig even more. And even if you don't build this exact jig, I hope you see how handy the Microjig match fit system is, the dovetail slot hardware, all the things that they provide to produce just about any shop jig or fixture you could possibly think of. I'm even considering adding some of these dovetail slots to things like the workbench or my assembly table just because it's that handy. And by the way, if you want to raise your game with some Microjig products, you could save 10% on your next order using my code TWW-MatchFit. So thank you to Microjig for sponsoring this episode. I hope you guys enjoy. I hope you build one. We'll see you next time.
And it's a bunch of B-roll. It's a bunch of B-roll. Pretty good.
It's more fun when I had people here that could laugh at my jokes. Now I have to do it myself.
Okay.
do that. Do a high five? Not your face, with your paw. This, high five. High five. High five. All right. Whatever.